Hi everybody. So today the entire focus is going to be on a single theorem that we're going to be focusing on. Now, if you recall, we talked about this when we did constructions and we talked about the centroid. If you recall, the centroid is the intersection of the three medians of a triangle. What we're attempting to prove, we kind of took it for granted before, but now we have the ability to do so. So we're going to do this using analytic geometry. We're going to be proving that the three medians of any triangle must all be concurrent. They must all meet at a single point. So that's going to be really important to us. But like anything, we should always have the plan. So let's start with the plan. So it makes sense here that for the first thing what we're going to do is we're going to set up a diagram and all relevant coordinates here to make things as easy as possible for us. And now, once we have, so basically what's going to happen here, so I'm just going to do a really brief sketch of this here. We're actually going to do everything else in a bit. So we're going to sketch a triangle. It's going to look something like this here. And then we're going to have our three medians. So this, and this. So because we're using algebra here, it makes sense for us to look at this case here. This point here, we want to show that this point exists and also lies on all three medians. So at this point, we have a bunch of lines, green lines that intersect with one another. So it makes sense that we should try to find the equation. So the next thing we're going to do is we're going to find the equations of all three medians. Okay, so that's the next phase. Phase 2 is going to be that here. Okay, phase 3 now. So once we have the equations, we're going to have equations. Let's call them E1, E2, E3. So now we're going to try to. Now we need to solve them. This point here is an intersection of the three equations here. So we have to show that the three equations all have the same solution at the end. So we're going to solve two of them. Since we can't solve three at once, we're going to solve them two at a time. We're going to solve a system with two of the three equations. Okay, and then finally in phase 4, what we're going to do is we're going to get a number, we're going to get some solution out of it, and we're going to show the solution lies on the third line, or the third median here. Okay, so we're going to be doing all of this. So basically our plan is going to look something like this here. Phase 1, we'll do all this, and then phase 2, we'll find the equations. Phase 3, we'll solve the system, and finally phase 4, we're going to show the solution lies on the third median here. Now, I'm going to warn you right now, this is going to be a very long video, and it's also going to be very heavily algebra based. So feel free to slow down the video or stop it, go back, take a look at it here. Just really make sure you understand how this is done here. Okay, so let's get started. Phase 1. We're going to set up the diagram and all relevant coordinates. So it makes sense here, considering what we did in the previous lesson here, it makes sense for us to try to set up this to make as many things 0 as possible here. So what we're going to do is we're going to try to draw a triangle so that one side is going to lie along the x-axis and also one of the vertices is at 0, 0. So we want to try to do that here. So we're just going to draw some random triangle like this here. Doesn't really need to matter about what kind of triangle you draw. We're just going to try to make this as general as possible here. So let me call the triangle here PQR. So here's triangle, here's point P, here's Q, and here's R here, right? Now P is clearly going to be the point 0, 0 because it's going to lie along the origin here. Now Q, the y coordinate is also going to be 0 as well. So now we're going to use some variables here. I want to try to avoid P using other letters here other than P, Q, and R. So let me use other. So I'm going to try to avoid using P, Q, and R. So I'm going to use other letters here. So I'm going to call this A. Now in this case, I'm going to use 6A here. Now normally we would use like 2A because we have midpoints here because of medians. But you'll see that 6A actually saves us a lot of time later, and you'll see why. And since we don't know where 6R is, I'm going to call it 6B and 6C here. Okay. And again, so we're going to be looking at this here now. Remember, with medians, we need midpoints here. So I'm going to go ahead and sketch all the medians here. So let me call this point here. I'm going to call this point here S. That's the midpoint of RQ here. So remember, it's always halfway in between. So it's half the sum of these things here. So it's going to be 6A plus 6B divided by 2. The nice part of that is 3A plus 3B. And then 6C plus 0 divided by 2 here, which is 3C. So we have that. So we can see we have a nice thing here. We have some nice integers. Okay. So now we're going to have T is going to be over here, point T like this, and now we have this here. So T is the midpoint of this. Notice that starts from 0, 0, so it makes things really easy. So that's going to be half of this, so that's 3B, comma 3C here, okay? And then finally, we're going to have point R down here somewhere. Sorry, not point R, point U down here somewhere. That's the midpoint here. And then it's a midpoint, but again, we have 0 to 6, so that's going to be 3A here. So we have a nice little thing. And now we can go ahead and sketch all of our medians here. So I'm going to draw PS, draw QT, and draw RU. Now, again, they look like they intersect at one point, but they could just very easily miss. I don't know what this point is, so we're going to try to find this point here. We're going to see where it exists, okay? So now, that completes phase 1. Phase 2, if you remember phase 2 now, phase 2 was to find the equations of the medians. Okay. Now, the nice part about this here is that if you look at the picture, even though there's a lot of variables here, the nice part about this is that all of these, we're actually going to use point slope form here, and you're going to see that we're going to try to do things to minimize the amount of work that we need to do, minimize the things that we have. So in order to find the equation of a line, of course, we're going to need its slope here. So let's start with PS because it's the easiest. Note that PS is the easiest line here because it has a y-intercept of 0. We know B is going to be 0 here. So we can use PS here. The slope is going to be, notice in this case here, it's going to be 3c minus 0 over 3a plus 3b minus 0 here, because it's from S to P. So we have this here. So that's going to be 3c over 3a plus 3b here, and that's a nice slope of c over a plus b. So note that in this situation, the slope is this, and the y-intercept is 0, 0. So that means the y-intercept is 0, and therefore we know that the equation of the line, therefore, is y equals c over a plus b times x here. Okay, so that's going to be one thing. Now, I know this is, so we'll take a look at this later on. Okay, now let's do the rest here. We now will look at QT. We're going to do the same thing with QT here. So QT, we see we're going to find the slope yet again. So the slope of this line QT here is going to be, well, let's see. QT is going to be 3c minus 0 over 3b minus 6a. That's equal to 3c over 3b minus 6a. We notice that all the coefficients have a common factor of 3, so I can cancel them. I'm left with c over b minus 2a here. Now, unfortunately, this line doesn't have a y-coordinate that's very nice here. It doesn't have a y-intercept very nice here. So we're going to have to use point slope form instead. But the nice part about point slope form, remember, it's y minus y1 equals m times x minus x1. I've got the slope here, and we have a nice little point here. And notice that we can pick this point because it has a 0 in it. In fact, it has a 0 in the y-coordinate. So the y minus y1 just becomes y. So this really becomes y minus 0. Well, y minus 0 is just y. And that is the slope c over b minus 2a times, in this case, x minus the x-coordinate at this point here, which is 6a. So therefore, we now have this, okay? So I've got these two equations so far. We're going to keep going. We're going to do one more here. Now we're also going to do RU. So RU here, again, we do the same thing. We find the slope of the line. So it's going to be 6c. So going again, we have this here. We have 6c minus 0 over 6b minus 3a. So 6c minus 0 over 6b minus 3a here, and that's 6c over 6b minus 3a. And we divide everything by 3 here again. We end up with 2c over, in this case here, 2b minus a here. And again, we see that just like before, back in our picture here, we're going to pick the point u. We have the slope. So we're going to pick the point u here. So it's going to be y minus 0 yet again. So it's y equals the slope, which is 2c over 2b minus a times x minus 3a here. So phase 2 is now complete. We now have the equations of all three of the lines. And they're all y equals things here, which is really absolutely fantastic here. Okay, so that's phase 2. All right, let's move on to phase 3. So phase 3, if you recall what we mentioned here before, phase 3 is, in this case, now we're going to solve two of the equations. Okay? So we're going to process this one separately. I'll see you on the flip side.